to getting the grant, isn't it? So Agland, as Andrew said, builds on ASSIST, and it's directly funded under the Landscape Decisions SPF. And I think I know at least one other Advent or Advances or whatever it's called. So there's a number of projects which NERC, who are leading the SPF, wanted to link to existing projects which were sort of strategic projects to get stuff done on the Landscape Decisions and demonstrate possibilities. So we were contacted by NERC about what we could develop building on ASSIST, and we came up with this idea under Agland. And you'll see whether ASSIST, I guess the big difference is ASSIST is very much field-based or maybe even regional, and Agland, its general approach is more UK or GB level of things. Again, it's CEH and Rothamsted with a bit of James Hutton involved as well. And we've recently started, it's quite a rapid start, so we're still building up a head of steam on it. And as well as building on ASSIST, it's building on other, building on other existing and past investments, like there's the Wessex Best project, which I ran, but also there's the Rothamsted Source to Nutrition project. There's, what's the thing in North Devon called? It's one of the Pioneer landscapes under DEFRA. Yes, so I may mention that. So that's the background, and the usual gubbins. We've got increasing competition between what we want to do with farmland, but also places for people to live, and also environmental degradation. A lot of that issue is going to be around farming. 70% of the UK is farmed. The 25-year environment plan makes some promises, including we're going to get outcomes at the landscape and catchment level. And so our take on this is we need to think about the landscape, all aspects of the landscape, I guess in a simple way, thinking about agricultural production, but also all the other ecosystem services, or what you want to call them, that we're getting from the landscape, and how you balance those out. So it builds especially on work package 4 in ASSIST, but goes much further than that. Yeah, this is some of the terms one has to use. How do I use the pointer here? Is it that? Yeah. So, I won't do that. So basically we want to understand this interaction between natural resources, environmental processes, and how we manage the land, bring in the sort of more social or farmer social aspects of it, and think about ways in which we can manage the land in the future to take account of these complex interactions, especially the supply and demand of ecosystem services. So the overall aim, new approaches, metrics and models to support policy decisions across a range of sectors, and how we manage future landscapes in terms of the agricultural landscape and the associated land uses. So this is a terribly complex set of objectives, which I think maps straight on to the work packages, so I won't go into great detail. But as I say, it's a sort of GB level, very much desk-based, using existing data sets, developing and testing modeling approaches, and looking, I think especially 4 and 5 are the key ones that we want to look at, demand and supply of natural capital ecosystem services, including food production, and also develop I guess sort of what you call decision support type tools for different policymakers to achieve this goal, the goal which has been around for almost decades now, multicultural landscapes, but as I say, focus on agricultural ones. Why is it doing that? There. And this is the work packages, which I'll go into detail in a minute about. We're developing new ways of classifying the land in terms of agricultural use and other factors. We're linking those ways of classifying it to the delivery of ecosystem services. We're studying those in more detail and validating those approaches through looking at well-studied landscapes in the UK, and then following through to provide decision support tools to help policymakers. There's a great load of algorithms, a great load of outputs there which link directly to what I'm going to go through now. So in detail, work package 1, I don't know how many of you come across the idea of land system archetypes. It's something that's been developed at the EU scale, and it's a way of classifying land use and land the sort of biophysical aspects of different parts of the land as it varies over space, to create types of land system. It's basically using a clustering type approach. It's a very nice approach applied across Europe. If you look at how those land system archetypes look in the UK, there's very, very few, and they sort of basically show the difference between the east and the west and the north and south. So we want to go into more detail using the rich data sets available in the UK, which look at things like soil, climate, topography, and various aspects of land use itself, to come up with these land system archetypes in a more detailed way. But very importantly, we then want to link those data to information on how farmers farm the landscape and the different farm systems you get. So further refine those into farm system archetypes, which is very important, because what we think is, whereas the land system archetype is something which is hard to change by management, although you might be able to move it a bit, from an agricultural point of view, is how you farm things, which may move your farm system from something which is maybe very degrading on the landscape, very productive, to something which more balances the different needs we have. That's the idea. And this will also provide an approach where we can look at trajectories of change in the future, maybe in response to policies. What we want to do, and this is the work package Andrew and I are leading, where we take those land system and farm system archetypes and determine what types of what levels of ecosystem services these different archetypes produce. So the idea here is to use so-called process modeling methods, so like the INVEST modeling framework, to use the data sets across the UK to say this archetype produces this level of this service, this archetype produces another. But these are great, but they're somewhat limited, so we will also explore statistical approaches using, again, these data sets available across the UK to understand delivery of services not well modelled by these process models, but also maybe to add on to these process models in a more sort of cross-validation and model iteration approach by adding new factors in which may affect the output, the level of the service. And we want to look at quite a range of services. So Andrew and I, yesterday, was it yesterday? It seems a long time ago, doesn't it? We're going through all these different services we might be interested in, how we might model them, what we might need for those. So we're going through that process of what we'd like to do. We'll hone it down to what we can do. And we're very interested in the second point, scale dependency, which we've not gone into great detail about, but obviously there are other methods. I don't know if Laura's talked about her grain changer approach here, but these sort of more clever, I can say that because I have nothing to do with it, clever methods of thinking about scale rather than just doing a sort of model selection process across different resolutions. So that's a very interesting area we haven't really thought about in great detail, but would be very good. And the final point, again, the focus is on agricultural landscape, so it's the old problem of agricultural production versus all other services and how you reconcile those. And, yep.
Are we allowed to interrupt in the middle of the talk?
No. Yes.
James, I was just curious, if you go back to the last one.
This one.
I was just wondering how that approach fits with your paper where you say that bundles are actually quite a bad idea because archetypes are simply another form of bundles in terms of understanding trade-offs and synergies for landscapes.
Well, I think that paper says, and since you're on it as well, it says doing bundles stupidly is a bad idea. Right. Doing it in an organised, clever way. Clever is the key word today. Don't do it stupidly. So, yeah, I agree. And I think we were talking a bit about this, weren't we, Andrew? About there is this sort of unsupervised clustering. You might get you get these clusters, these archetypes. What does that tell you? Does that link to services in a sensible way at all? And one thing we're thinking about an iterative process where you maybe come up with the archetypes in a stupid way or an unsupervised way. Think about what are the key variables or predictors which link to services, and maybe either rerun the whole thing or refine these archetypes based on these key drivers of services, and linking it to the context dependency as well.
It's a nice idea. I tried that with,
Yeah.
I was trying to figure out how could you come up with sort of multivariate sort of archetypes of sort of land use change type things. I thought, yeah, that's what you can do. You just take, core variables and you slowly build it up to different kinds of variables. It doesn't work because of the variance structure. The variance structure changes every single time. And every single time, you don't really know what's going on. You get different results, but you still don't quite understand it. I mean, if you guys could solve that,
Okay.
I'm skeptical.
Right, okay.
Because of the variance structure, because clustering is always driven by the variance
Yeah.
of the data.
Yeah.
Every time you add a new layer,
It all
changes.
Yeah, that's a good point. I mean, as I say, I haven't said this, we haven't started that yet. We've got a couple of postdocs starting soon, so they've got to delve into it, but it would be useful to chat more about that with Bex as well. So this is a great opportunity to actually raise these issues now before we do these things, and Jenny's got a hand up there as well.
Yeah, because it's linked to that. Otherwise, I wouldn't want to interrupt your free flow. More of a political point, really, that I can see how it's very convenient to define farm archetypes, and all you've got to define them is what exists now. But if it was actually going to be really beneficial for both economics and ecosystem services, say, to have a new type of farm that we've never seen before, wouldn't you want to discover that has a mixture of variables that say sustainable intensification in a way that's very intensive in some areas and very wild in others in a way that we've not seen before, for example?
That's an interesting point. I guess I can't immediately think how one does that apart from through some sort of stakeholder engagement process about what new ways of doing things might we come up with and how might they map onto those.
Well, or breaking down the elements into, rather than modelling at the farm level, modelling at the
field,
parcel level, and allowing any parcel to become anything. Obviously that's unrealistic in a different way, but still might lead you to some new ideas.
Yeah. Yes, interesting. Yes, I mean, I think that trying to think about new ways of doing things has been quite, I mean, it's an element of assist as what new things might we do and how do we step outside the box. And there's a practical level of getting farmers actually to do new things, which they're very, like with most walks of life, nothing against farmers, they're very risk averse, and so it's how that actually happens. And some of the options people come up with are not very rounded in what the general approach is. So I think, thinking off the top of my head, the only way I can think of doing that is linking what we're doing in assist about looking at new approaches to what we do here, and then maybe, we don't know yet, maybe some follow-on to assist where we actually try to do more radical stuff on a smaller scale, which would feed into that. So I guess one could come up with stuff, but it's how we know what the real effects will be and how much we second guess those effects. And I guess what I often find with conservation plan is a lot of wishful thinking there without actually knowing what the real effects will be. And it's sort of chicken and egg problem. But I think having said that, I think it's a really good point about how you then move to the future. Paula.
So while everyone's interrupting you, so sorry. It kind of builds on that, but also on your previous slide.
This one, the previous.
Yeah, where you had the statement, I think it was on this one. No, I think it was on work package 1.
Oh.
But you had something about optimising land use, and I wanted to know, there you go, optimising land use at the end of the second bullet.
Yeah.
And actually, so what are you optimising for, at what scale? So is that the farm or the whole landscape? And there's a lot of people who don't think optimisation is even feasible or possible because there is political and societal choice in actually what we want our landscapes to deliver. They can't have everything, there is always a choice. So what does that mean? Because again, that is very much related to your approach of clustering and use.
Yeah, and that's an issue for assist. So the assist work package I'm helping to lead has an optimisation aspect there. So the Rothamsted partners are very interested in optimising at the field or small farm, a few fields level, these different things, and that's very much focused on the sort of yield gap, these very specific things about what you're doing to the crop, but also these other services. I guess I'm more interested in the more landscape or larger scale, where it would be this optimization across a range of services and yield. Having said that, we haven't gone into great detail about how one does that. There are obviously these methods we've used a bit before, these sort of Pareto boundaries and that sort of thing. So I think technically it's possible. I think computationally it's quite intensive, and also it's what you could say equally. I'll come to you in a minute. Equally weight everything, or you have some stakeholder engagement. Say, well, yeah, this is really important. This is low importance. If you vary the things, obviously that changes. We've done that a few years ago for agri-environment options, and interestingly, if you didn't weight things, we found the agri-environment options that sort of do a bit of everything are the best. So you're mediocre for everything, and that's where your weighting is so important. So that's a long way of saying, yeah, we're thinking about it. We haven't gone into the crunch of how to do it and linking to what other people are doing. So again, it's useful to have this feedback.
Yeah, right. And I guess the issue is do it for the landscape now, but also to do it in the future where you'll potentially have completely different socio-economic and political drivers.
Yeah.
So actually you might take away a huge amount of the demand if you look, I don't know if your models are looking at dietary change and some of those socio-economic changes, which means actually you might free up land. So actually it might not be, it might be actually what we're going to use this land for now, and in any cases we don't need it for food.
Yeah.
So will you go into some of those interactions?
Well, I guess the approach here, and Andrew will correct me if I'm wrong, we are thinking about very near future or now. So now, an alternative now in a sense, as Assist is taking. But as you know, there are other projects going on which are thinking about changes over the next few decades, and we haven't promised to cover that sort of idea here, but we can link across these projects to think a bit about that. And I think, who was saying yesterday about, it was Simon, wasn't it, about sort of socioeconomic futures, thinking about those in a spatially explicit way would be quite cool, because we have these, as you know, we have these narratives, but trying to make those spatially explicit is quite complicated. So I don't know if you talked about speed and other stuff to people here. So we have a totally different project, which is under CEH core funding national capability, where part of it is trying to get a consistent and coherent set of projections of climate change, working with the Met Office, land use change, socioeconomic futures, and various other things, including biodiversity and pollution. And at the moment, those projects are going in parallel, but there's an opportunity, without promising too much, I was very aware of promising too much, about bringing these together to think about that future. But I think, as you're saying, that we know where stuff is now, so tweaking that a bit is relatively easy, thinking where things may be in the future. So even in the near future, we may find in 20 years that the mountains of Wales, I don't want to be too, hopefully this isn't too politically unsound, may be ungrazed by sheep, but going through some rewilding process. You know, we have no idea which way it's going to go, or it may become some tourist theme park or something, or...
That's pretty unlikely.
Yeah, have you been to Wales? So I think it's those uncertainties as well, which I know is a subject. So it's, as I say, you want to say something? As I say, these are really good feedback, and it's. I don't want to give the impression we haven't thought about them. We're thinking about them, and it's really good to have this stuff now, because we haven't gotten to grips with it yet. So there's loads of people we can talk to about making sure we're not reinventing the wheel and we're doing something clever. You had a...
Yeah, I'm just going to comment on thinking about optimization, because it's actually it's kind of conversation I've had privately a few times, including in the Eagle last night when everyone else was at the music. But we usually start off by saying that the optimality in model world is at best of indirect relevance, because we're interested in good decisions for the real world. And certainly, I mean, I know much better than this the area of energy systems modelling. And there, I think things have gone a bit too far down the track of formal optimization modelling being regarded as sort of gold standard. And one of the problems you get, one of the problems one can get, is that the burden of putting the formal optimization layer on top can become so great that in the underlying system model, you have to, well, you can get to the stage where you essentially have to throw out reality,
Right.
and or credibility in order to do formal optimization. So it may, I mean, it's also can be quite commonly the case that really you have say in strategic decision making, you have a relatively short list of high level options.
Mm.
So I think when we're talking about optimization, or I think we just need to remember that formal optimization modelling is not the only thing one might think of.
Yeah.
I mean, ultimately, if we're interested in good decisions for the real world, then one needs to start from that. Because one challenge for that in universities is that you're currently building bigger and bolder, certainly in energy systems, bigger and bolder optimization models using cleverer and vendors decomposition methods. Solving them is a very good way of getting papers published in top journals, and so it's a practical where you, from really supporting practical decision making, where you get your reward on earth as opposed to in heaven can be a bit less clear.
Yeah.
But I think that's an important dilemma.
Yeah, that's really valuable point made there. That's really useful. And I think an extra complication in the sense to think about landscapes or larger is the spatial configuration is part of that optimization. So that's a really horrible aspect where you're shifting things around, and a certain configuration may give you totally different outcomes to another. And so it's not just what a particular thing gives you, it's where it is in context with the other things. And so you can imagine that getting, breaking the computer.
Yeah, no. Well, I was thinking of proposing for Monday the session a bit like the next one on I usually call it decision making against very complex backgrounds, things like that, or if you're looking at overall energy policy where the background is literally everything.
Yeah.
And so the system you're dealing with is vastly more complex than any model you could possibly build. And the question of what then is, I think, is very rarely addressed head on. And as part, I think as part of that, this long-term agenda, that's perhaps an interesting thing to think about. I mean, in terms of this kind of scale of work, I think any project was really addressing that simply because you would need multiple disciplines. It's just too big for the present call. But for what could be done in the longer term, I think there is something distinctive there.
Cool. Great. Well, that's really useful feedback, Peter.
But this is from the wonderful state of not knowing anything about the problem. In healthcare, we found that if we're fitting models to patients, clustering in model space is more efficient and seems to be better than clustering in data space. So you cluster on the fitted model parameters rather than clustering on the actual measurements.
Right.
I've no idea what it is.
Is that because you're getting rid of the variates?
Well, in healthcare, you're looking at more biological reasons for why someone has problems with their heart. What you measure is what you can measure, not what you really like to measure. So you get deeper into the structure, but of course it does bring in the model discrepancy wrong. The model might be wrong, but it seems to work better in a number of instances.
Oh, interesting.
Elaborate. So do you mean you're doing something like PCA on your different predictor variables to get them orthogonal, or is that you need something different now?
We're actually going to fit a process-based model to the data, and then cluster using the parameters estimated from that process.
Okay.
So there's a ratio, you've got model world here and you've got real world here, and we map things into model world, and the clusters seem to separate better.
So they're clusters of different responses. So you model different processes.
It's the same. It's the model of the human heart.
Right.